Making accurate waveform measurements on a TBS1000B or TBS1000B EDU oscilloscope is easy to do once you know how. There are several techniques for making measurements, and we'll cover each one briefly in this video. For this video, we'll make measurements on the calibration output of the scope. To get a stable waveform, I'll use the AutoSet function, which also performs a series of automatic measurements as soon as it finishes analyzing the waveform. We'll talk more about automatic measurements later. Before you make any important measurements, make sure you adjust the waveform to use as much of the display as possible. This will give you the most accurate results. You can quickly check timing relationships and voltage values just by looking at the screen. Based on the scale settings, each horizontal division represents 500 microseconds and each vertical division represents 1 volt. Since the period of our signal is 2 divisions long, we can multiply 2 by 500 microseconds to get a period of 1 millisecond. The signal is also 5 divisions high, so we can multiply 5 times 1 volt to get the amplitude of 5 volts. Cursors can also be used to make voltage and time-related measurements. They incorporate the scale settings to read out directly in volts and seconds. To measure voltage, set the measurement type to amplitude. This brings up 2 horizontal cursors. Since the signal is connected to channel 1, I need to make sure that it's the source for the cursor measurement. We'll use both cursors to make the peak-to-peak measurement. I'll set the first one to the highest point of the waveform. Next, I'll position the second cursor on the lowest point. The delta V measurement shows the voltage difference between the cursors. In this case, it's the 5 volts peak-to-peak voltage of the signal. The process for taking time measurements is similar. When I switch to time mode, the cursors switch to a vertical orientation. I'll position the first cursor on the first rising edge of the signal. Next, I'll position the second cursor on the second rising edge to encompass 1 period of the signal. The delta measurement shows time between the cursors. In this case, it represents the period of the signal. Also shown in the display is the frequency, which is the automatic calculation of 1 over the period. Automatic measurements use the scope's processing power to perform calculations on digitized waveforms. There are 34 measurements available on the TBS1000B oscilloscopes, going well beyond the simple delta T and delta V measurements we've just made with the cursors. Just like cursor measurements, I need to choose which channel I'll be measuring. Then I specify the type of measurements I want to perform. In this case, a period measurement. For automatic measurements, the scope needs enough information in its memory. To perform a period measurement, the scope needs more than 1 complete cycle of the signal. When the scope does not have enough information, it shows a question mark. As you can see, when enough information is provided, the automatic measurement provides the same information we saw when we used the cursors, but in this case we didn't have to position the cursors. Now we'll add a peak-to-peak voltage measurement. The reading is a little bit higher than what we saw with the cursors. It includes about 1/10 of a volt of combined overshoot and undershoot we didn't see before. So far we've taken automatic measurements we could have taken manually, but some measurements are just not that easy to take manually. Let's add root mean square voltage. This measurement gives us the RMS voltage for the first cycle on the display. Let's add a few more. With the TBS1000B oscilloscopes, we can view up to 6 different automatic measurements simultaneously. We've shown you a few techniques for making measurements on the TBS1000B oscilloscope. Put these techniques to work to characterize and evaluate some circuits of your own.